Today I am presenting our project titled Bayesian Network to diagnose corona infection. This project uses a probabilistic graphical model called Bayesian network to predict COVID-19 infection based on the symptoms and the medical conditions. Unlike simple rule-based diagnosis system, we apply Bayesian inference to calculate the probability of infection using symptom evidence. The probabilistic approach makes the system more reliable and suitable for the healthcare decision support, especially during pandemic situations. Here, the second slide shows that the code setup. In this slide, we set up the Python environment required for our implementation, and then we imported the necessary packages for the program, which is pandas for handling datasets and numpy for numerical operations, skitlearn for model evolution, pgmpy for building and performing inference of the Bayesian network. So these libraries help us in data processing, model creation, probability computation, and performance evaluation. Dataset and symptom definition was defined in the third slide. Here we define the dataset structure used for training the model. Each symptom such as fever, dry cough, fatigue, breathing difficulty, loss of taste is represented as a variable in the Bayesian network. Each symptom has two possible values, either yes or no. All these symptom variables are connected to the target variable called COVID-19, which represents whether a patient is positive or negative. Then this structure allows us to define conditional probability between symptoms and the infection status. In this section, we construct the Bayesian network structure. Each symptom is represented as a node and the diagnosis COVID-19 is the main target node. Directed edges are drawn between nodes to represent dependency relationships. For example, symptom like fever, cough influence the probability of COVID-19 infection. This graphical representation helps us mathematically model uncertainty and performance probabilistic reasoning. So, inference and probability calculation. Now we perform inference using the variable elimination algorithm. When we provide symptom values as evidence, the model calculates the posterior probability of COVID-19. Instead of giving only a yes or no answer, the system provides a probability score such as 0.85 or 0.90, like that. The probability lies between the zeros and ones. So it will shows the values in between of 0 and 1. The probabilistic output makes the diagnosis more realistic and useful in the medical decision making. So in this slide, we define the accuracy calculation. To evaluate the performance of our model, we split the dataset into training and testing sets. The model learns pattern from the training data and is then tested on unseen data. We calculate the accuracy score by comparing predicted results with the actual labels. This helps us measure how effectively the Bayesian network diagnoses infection. Visualization. This slide shows a bar chart representing symptom frequency in the dataset. It displays how often each symptom appears among the patients. We observe that symptoms such as fever and cough occur more frequently in infected individuals. Visualization helps us understand the data distribution and support the interpretation of our model's predictions. Then here we can see the prediction result generated by the model. For each patient case, the system displays the actual label and the predicted label. In both match, it indicates correct classification. This confirms that the model is functioning properly and generating reliable predictions. Final accuracy and interpretation. This slide shows that the final accuracy percentage is um, higher. Then we move on to the program session. In this program, we first import the necessary packages like import pandas as PD. We import the pandas library and assign it the alias PD. Pandas is used to create and manage structured dataset in data frame format, which makes data manipulation and processing easier. Import NumPy as NP. We import NumPy as NP. NumPy is used for numerical operations and efficient array handling, especially when performing mathematical computations. From sklearn.model selection, import train test split. This function is used to split the dataset into training and testing sets. It helps evaluate the model on unseen data. From sklearn metrics, import accuracy score. We import accuracy score to evaluate the performance of our model by comparing predicted values with the actual values. From pgmpy.models, import Bayesian model. We import the Bayesian model class from a pgmpy to construct the Bayesian network structure, which represents probabilistic relationship between symptom and COVID-19. From pgmpy.inference, import variable elimination. We import the variable elimination algorithm to perform probabilistic inference in the Bayesian network. Then data equal to, we create a dictionary containing a symptom data. Each key represents a variable and the values represents the observation. Here, symptom representation fever is to 101. Each symptom is represented as a binary variable where 1 indicates the presence of symptom and 0 indicates the absence of symptom. COVID-19 is to 101. This the target variable. 1 indicates the COVID positive and 0 indicates the COVID-9 negative. df is equal to pd dot data frame data. We convert the dictionary into pandas data frame so it can be processed and used for training the models. Model is equal to Bayesian model. We create the Bayesian network structure by defining directed edges between the symptoms and the target variable. Fever COVID-19. This defines a directed edge from fever to COVID-19, meaning that fever influences the probability of infection. A function in this model.fit.df. This function trains the Bayesian network using the dataset. It automatically learns the conditional probability tables from the data. Train test split. X equal to gf.drop. COVID-19 axis equal to 1. We separate input features by removing the target column. Y equal to df of COVID-19. We store the target variables separately for prediction and evaluation. Train test split. We split the dataset into 70% training data and 30% testing data to evaluate performance on unseen samples. Inference. Inference equal to variable elimination of model. We create the inference engine using the trained Bayesian model. Result is equal to inference.query. This computes the posterior probability of COVID-19 given the symptom evidence. Prediction equal to result.values.argument max. We select the class with the highest probability as the final predicted output. Accuracy score of y-test and prediction. We calculate the percentage of correctly predicted cases. Print accuracy, accuracy star 100. We display the model accuracy in percentage format. Plot bar of symptoms and counts. We create a bar chart to visualize how frequently each symptom appears in the dataset. Thank you.